Okay, so we can delete that. And let's go ahead and make sure we save real quick. The next step is that we actually want to put this set of relationships in time so that we can see these points fall. So let's go to the Kangaroo tab and the Kangaroo subtab, and we'll grab the Kangaroo Physics object. All right, so this is the kind of central object that we'll be using for all of our simulations. We can't actually do anything with Kangaroo unless we're using this object. I guess you could use a couple of these utility objects, but if you want to see things moving, right, we need to, and we want to have a kind of live form finding file, we need to be using the physics engine. Okay, so let's examine what this object asks for. The first is all force inputs, right? So any force that we're creating for our simulation needs to come into this input, right? And a quick note, it needs to be on a list. We can't send data trees into the force object's input. Okay, next we have an optional input if we need to anchor any object to a specific location in space, right? So that's where any anchor points are going to be. For now, we're not going to be using this one for this exercise, but we'll come back to using it a little bit later. Next, we have the simulation settings input, which the default ones that are already built into this object are pretty useful. We don't need to change them too much, but if we do need to change them at some point, we would use a different object called Kangaroo settings to define things like drag, static friction, how many times it should calculate before actually giving us a result, so that's called sub-iterations, etc. If we wanted to change any of those things, we would have to use this object and plug it into this input. All right, and then the next object input is geometry that we want to transform. So this is anything that you want to go along with your particles, springs, or whatever type of physics-based relationships you're establishing. Any geometry you want to move or be modified by all the physical forces would go into the geometry input. And then lastly, whether or not we need to reset the simulation is going to be based on a Boolean toggle, which allows us to start it over or initialize the simulation. Okay, so for this first exercise, all we really need to connect into the first few inputs is the unary force. This is going to go into our force objects. Now the Kangaroo object now is happy. It's light gray as opposed to orange. But in order for anything to actually happen, we need to include a couple more objects. The first is related to the last input here, the simulation reset. We need to make sure that under params input, we use a Boolean toggle to determine whether or not we need to reset the simulation or release it, say start it, right? All right, so I'm going to leave that as true. That means that it's going to be reset and nothing's going to happen. And at the same time, I need that other object that we were talking about that allows our simulation to be calculated through time. And that is going to be under the Utilities tab, Timer. Right? This is provides a mechanism for updating solutions at specified intervals. Right? So here we have our timer, and this object works differently than just about every other object that we have, in that we need to click and drag, and we get a different type of wire, and we connect it to the object itself, not to any specific input, but the object itself. Right? So that will say that in this interval, this object, its solution will expire, and therefore cause Grasshopper to resolve the input, right? All the inputs into this object. So what this Kangaroo object is doing is storing the current values. Whenever it expires, it calculates the next one, but remembers the previous. and then repeats at this interval, right? So if we want a smooth simulation, let's right-click the timer and turn the interval to something like 20 milliseconds. All right, so that was a little bit long in terms of getting this object all set up, but once we do it once, it becomes pretty quick, right? Just that we need to remember all force objects go into the first input. That's particles, springs, unitary forces, etc. And the only other thing we absolutely need is the simulation reset and the timer. Okay. So the other thing that we mentioned in the presentation was that there is a global block for the timer, right? And that's down here in the Windows system tray. If you don't see a green check mark or a circle with a cross through it that's red, double check, and this is going to be based on which Windows version you're using, double check that it's not in the hidden icons. If it is, go ahead and drag it down onto this portion of your system tray so that it's always visible. Okay, so if you've done that successfully, make sure that the global timer block is red and is off, or the timers are blocked. Then we can go ahead and toggle our Boolean here to false. This will allow the simulation to start whenever we release this timer block. So I'm going to zoom out for a second, and let's go ahead and release our timer block by double-clicking here, and we should see some points fall. I'll stop it. Now, the simulation is essentially paused. The points have fallen. I have not reset it, and the timer is blocked. All right, so once again, to release the simulation, to let it start again, we're going to double-click this icon in the system tray, or double-click it again to block it. Okay, so let's take a second, make sure that everyone was able to get that working. We've now done our first simulation. If you want to, you can reset the simulation, toggle it back to false, and then release the block again, and we'll see our points falling again. Okay, so if you have any questions about that, go ahead and drop them into the window. We'll address them now before we go any further. And while we're waiting for a couple of questions, let's maybe think about what exactly these points are and what exactly these points are. See if you can find where they're located inside of the Grasshopper file. And while you're thinking about that, also think about why all these points are essentially in the same position relative to each other, despite the fact that they're under this unitary force. If you have any suggestions, go ahead and drop them into the questions window. Okay, so we have some suggestions as to what we're seeing here in our viewport, and you are correct. Here, this set of points here, these are our division points, and they're going to be stuck on our original curve, right? Because these are parametrically defined, but not actually physical geometry yet. So these don't have any mass or forces applied to them. So I'm going to group this and label this my division points. Okay. What we're seeing down here is a collection of points that are the result of the simulation. So if I click on my Kangaroo object, I might notice that these highlight green, and here out of particles out we have a series of points, right? So whenever we're using the unitary force in coordination with our division points, Kangaroo is automatically creating particles at each one of those locations and applying this force to each one of them. So what we see down here are the particles out. Okay, and there are also a couple of questions about getting the Kangaroo object to work. It's red. If it's red, that means that either something has gone wrong in the file that it doesn't like. For instance, if you accidentally put the unary force into the wrong input, or if you skipped the portion of the install process where we right-clicked and unblocked these objects once they were in the Grasshopper folders, libraries folder, it won't actually work. So you have to unblock those two files whenever you copy them to your library. So make sure that those two things are correct, and if you have any other issues, you have a red object or anything, send us a line and we'll try and get that resolved for you. All right, so we're getting some good questions, and let's go ahead and address them now. One of them has to do with what's coming out of the Kangaroo object. All right, so let's grab a panel and examine what we're getting as a result. All right, so coming out of out, this is going to be a number, right? So if I follow that number once I release my simulation and my timer block, out here is giving us a message of 10, right? And 10 should be the same as the value for the sub iterations. So out is just giving us a little message, which right now is not very specific or interesting, just 10. Iterations, on the other hand, is how many times Kangaroo is updating, right? So if I reset, we're back down to 0. I can release my timer block, and we can watch that number increase, right? And remember, each step is actually 10 iterations. That's based on the settings that are here in this, this input. All right. Then we also have particles out. These are the point locations of our particles, right? So even though particles have mass attached to them, what we're getting as particles out are points so that we can use them within the context of Grasshopper. And we didn't use anything as an input for geometry, so nothing's coming out of geometry out. All right, so really great questions. Now, we said that any particle has to have mass attached to it in order for it to be not just a point, but a particle. So if that's the case, we haven't assigned any masses to our particles yet. Or, sorry, we haven't assigned any masses to our points yet. So let's take a second and think about why the Kangaroo object is working, even though we haven't given any masses to these objects. If you have a suggestion about why that is, go ahead and drop it into the questions window. And while you're doing that, I'll just go ahead and connect up the unary force one more time to a panel so we can see what's coming out. All right, so the answer is that the unary force is applying a force to a point, right? By default, that's going to automatically create a particle, right? So it's going to assume that the mass is 1 and create a particle that we can use. But that doesn't have to be the case, right? We can use our own mass value that we assign to each one of these points so that we create a more specific particle.